Hi everyone, this is Anu, and in this video, I'm going to be discussing the solutions of the LeetCode Biweekly Contest. And not just the solutions, I'm also going to be sharing with you some tips about how you can solve questions that you haven't seen before, and what are some of the key observations that you can make when you look at a particular problem. So let's get into the video. So the first question that we had was minimum right shifts to sort the array. So you're given a zero-indexed integer array nums of length n containing distinct positive integers. And what you have to do is that you have to return the minimum number of right shifts required to sort array nums and -1 if this is not possible. So this was a simple brute force problem. Okay, so what you had to do was you had to just brute force the particular list. So you had to shift it right times, any number of times. So we know that there are n unique shifts that can be performed on any array of length n. So that is what you had to do in this problem. It was just a simple brute force problem. And as you can see, this is the solution that I have implemented. So I have used an optimized approach for particularly like right shifting the array, but you can use any other brute force solution that you know. And for every right shift that we do, you have to check like if the nums is sorted, then you can directly return I plus 1. And I have taken this modulo nums dot size to take care of this particular case. So when you have an array that is already sorted, you can also take this as a corner condition, and then maybe you can avoid this modulo nums dot size. But I have added it in this way. And if for any particular right shifts, so as I said, like there can be at most n unique right shifts. And if it's not possible, then you can directly return -1. And that is the first question. So let's start with the second problem, minimum array length after pair removals. So you're given a zero index sorted array of integer nums, and you can perform the following operation any number of times. So what you have to do is you have to choose two indices, I and j, such that I is less than j and nums of I is less than nums of j. And then what you have to do is you have to remove the elements at I and j from nums. And what will happen is the remaining elements retain their original order and the array is re-indexed. So basically, let's say that if I have some numbers like this 1 2 3 4 and 5, and if I want to remove these two numbers, what will happen is after this my array will finally look something like this 1 3 and 5. Okay, and what we have to do is here we have to return an integer that denotes the minimum length of nums after performing these operations. So the thing that you have to concentrate on here is that you have to find the minimum length of nums, right? Now what we can see here is that here the answer will be 0, because for 1, like we can remove this pair 1 3 and we can remove this pair 4 9, and then the answer will be equal to 0. Similarly, here again we can form this pair 2 3 6, and we can form another pair 6 and 9. Now coming on to the third example, what will happen here is that the answer is going to be 1, the minimum length that is going to be remaining, because there is no way we can remove this particular one, right? So if I have something like 1 1 and 2, what will happen is that I can remove this 1 and 2, but I can't remove this 1 1. Like there's no way I can remove this particular one. Or if I try to remove this one, then I will have something like 1 and 2, and then this one will be left, right? So no matter what I do, at least the minimum length possible of this array is going to be equal to 1. So one thing that we can clearly see from this particular problem is that if my array is of odd length, then the answer is always going to be 1, at least 1, right? Because let's just take any particular example. Suppose I have something like this 1 2 3 4 and 5. Now what will happen is that at any step I'm removing two elements from the array, right? So what will happen is, let's suppose I remove 1 2, right? Then I remove 3 4, but then this 5 will be left. And not just this 5, like if I have an array of length 7 also, so if I have something like 1 2 3 4 5 6 7, then also the answer will at least be 1, because at any moment of time I'm always removing 2. So if I have an odd length array, the answer will at least be equal to 1, at least, right? Now let's look at like how do we go ahead and solve the problem. So one thing that we can notice is that we can always, if it has distinct elements, right? Now let's just take the case of, let's take any other example, right? Let's say 1, 2, 2, 3, 3, and 4, 4, and let's say we have something like 5, right? Now what is the minimum length possible for this particular array, right? So what will happen is I can remove this 1, 2, right? I can remove this 2, 3, I can remove this 3, 4, and I can remove this 4, 5, right? So the answer here is going to be 0. Now let's have a look at any other example. Let's say 4, 4, 4, and 4. Now for this particular case, what will be the answer? The answer is going to be the minimum length possible is 4. Now why is that? Because these elements are equal, right? And my question specifies that I can only remove elements if nums of I is less than nums of j. So clearly, one thing that will not help us in decreasing our answer is when we have equal numbers, right? So this is the thing that we have to focus on. If we have equal numbers, right, then it is not possible to remove these particular element. So what you can do is you can calculate the frequency of each number, right? Now what we are going to do is we are going to calculate the frequency of each number. Now what I have to concentrate on is the maximum frequency that any number can have, right? Because again, what I'm concentrating on is that I cannot remove equal numbers, right? These equal numbers are the problem here. So what I'll do is I will calculate the maximum frequency that any particular element will have. And now what I'll check is if this maximum frequency, right, if it is less than or equal to the sum of basically the sum of frequencies of the remaining numbers. So let's say basically if I have, let's say the maximum frequency that I have is max, right? And the length of the array is, let's say, len, right? So if this is max and this is len, and if this max, right, if this max is greater than 2 into len, right? So if basically this max, if it is greater, 2 into max is greater than len, then what that means is that all of the remaining elements, right, they cannot cancel out my number which has the maximum frequency. So in that case, I'm simply going to return 2 into max minus len, right? But if this is not the case, then again we will have only the case which I discussed previously, that if the length modulo 2, right, if that is not equal to 0, that means this is an odd length array, then in that case I will return 1, otherwise I will return 0, right? So the thing that we had to notice here was that we had something like this, nums of I is less than nums of j. So the only problem where we were not able to reduce the length of the array to the minimum size is when we had equal elements, right? And if the frequency of the element which has the maximum frequency, if it is greater, if it is two times of it is greater than the length of the whole array, right? That means everything, like let's take this particular example. Let's suppose we have something like this, 1, 1, 5, 5, 5, and 5. Now no matter what I try to do, these two ones, right, they cannot cancel out all of the fives, right? At max they can cancel out two of them, and then the minimum length of the array will be 2. So that means the only thing that is determining our answer is the frequency, maximum frequency of any element. And I know that this question is a bit tricky to understand, but then again, like this is what you had to notice here, that the only problem when that we are getting while we are reducing the length of the array is when we have numbers, we have equal numbers, right? And then what you have to do is you have to find the maximum frequency of any particular number. And now all the other numbers can cancel this element with the maximum frequency. But if this particular maximum frequency, right, if like in this example, it the frequency is greater than length by 2, where length is the array of the length of the whole array, then that means it can only at max cancel out 2 into max minus length, right? The other ones are going to be left. And this is the solution of this particular problem. Now let's move on to the third problem. So in the third problem, what we have is that you're given a 2D integer array coordinates and an integer k. So we have these coordinates, basically xi and yi. And what we have to do is, basically in this question, we define the distance between 2 points as x1 XOR x2 plus y1 XOR y2. And this is the main part, right? You have to calculate the number of pairs such that I is less than j and the distance between points I and j is equal to k, right? So as you can see here, these are the coordinates that are given to us, and this is the k that is given to us. And what we can see is that for the 0 and 1 pair, if we calculate this distance, right, which is nothing but x1 XOR x2 plus y1 XOR y2, this should be equal to k, right? So obviously one brute force solution that can come to your mind is that you can basically run two for loops, right? So what you can do is you can just run for int I is equal to 0, I is less than n plus plus I, and then again for int j is equal to I plus 1, j is less than n plus plus j. You can just calculate the current distance, right? Let's say I have some particular current distance, and you can just check if this current is equal to k, then you can just do count plus plus. But then again, the complexity of this particular solution is going to be O of n square, and this is not going to work. Clearly, since our array length is 5 into 10 to the power 4, right? So 5 into 10 to the power 4, if you do a square of this, then it's almost going to be 25 into 10 to the power 8. Basically, this will not pass the time limits, because if you want to implement any O of n square solution, then the constraint should, and this particular value, right, it should be at least less than equal to 10 to the power of 6, right? So now what we have to do is we have to optimize this particular problem. Now, how do we go about optimizing this problem? Let's look at the constraints again, right? This part cannot be optimized. And again, xi, yi is still 10 to the power 6. Again, this cannot be optimized as well. Now let's look at this part, that k is equal to at max 100. Now this is the part that you have to focus on. What happens if I do something like this, 5 into 10 to the power 4 into 10 square, which is the worst time case. Like let's suppose in the worst case, k will be equal to 100. Now this value is equal to 5 into 10 to the power 6, right? And like I said, for any particular solution, it should be at least less than equal to 10 to the power 6, right? So basically, we can do something in O of n into k time, where n is the length of the array and k is the number that is given to us. Now, let's have a look at our equation again. So what was the equation that we had? This was the equation, right? x1 XOR x2 plus y1 XOR y2 should be equal to k. So that means, let's just have a look at it again. Sum a plus b should be equal to k, right? So that means at any particular time, what I can do is I can iterate from I is equal to 0 till I is less than equal to k, right? And what I can see is that, let's say a is equal to I, the value of this part a, which is a is again x1 or x2, is equal to I, then obviously what will be b? B will be k minus I, right? If we have I plus b is equal to k, that means b is equal to k minus I, right? And what is b here? B is y1 XOR y2, right? So the value of b here is going to be equal to k minus I, right? Now what you can see here is that we have just reduced this problem into a problem that we know, right? Now what we have to do is, we know that a is equal to I and b is equal to k minus I. And then we also know that a is equal to x1 or x2. So what exactly we are trying to say here is that a is equal to I, that means x1 XOR x2 is equal to I. So that means if I'm at any particular x1, right, then I know x1 if is equal to I XOR x2. So if I store the frequency of this particular x1 in a map, right? Then for any particular x2, I can just get this frequency x1. Similarly, what we had was b is equal to k minus I. Then y1 or y2 is equal to k minus I. Then again, y1 is equal to k minus I XOR y2, right? This is the XOR property. If you apply XOR of y2 on both sides, then this y2 will cancel out, right? And now what I can do is, as I can see that I have this equation now ready, that for any particular x2, right, I need to find this value, I XOR x2. And for any particular y2, I need to find k minus I XOR y2. And these values, the frequency of these values, they can be stored in a map. And this is how I get the solution, right? So what we are going to do is, we are going to take a hash map, right? So we are going to take a hash map of, we need a 2D hash map here. Why? Because we need xy and xi and yi, right? So I'm just going to take a hash map here. Now you can code in whatever language that you like to code in. I am coding in Java. So let's iterate over the array, right? Coordinates dot size plus plus I. Now the current x that I have is going to be equal to coordinates dot get I dot get 0, that, and the current y that I have is going to be coordinates dot get I dot get 1. Now what I'm going to do is, I'm going to iterate over all the possible values of k, right? For j is equal to 0, j is less than equal to k, plus plus j. And now here what I'm going to implement is, basically I'm trying to say that my a part is equal to j and b part is equal to k minus j, right? Now recall again that a and b were nothing but x1s or x2 and y1s or y2. And as it is an addition problem, so if I have a plus b is equal to k, then obviously if this part is equal to j, j plus b is equal to k, then b will be nothing but k minus j only, right? So what I'm going to check here now is that if my map contains this key, which is x XOR j, right? This is what we had to find here. Again, I XOR x2, right? Now, if it contains that, what is the next point that I have to find? If it also contains the corresponding y value. Now, what was the corresponding value? K minus I XOR y2, right? So, the corresponding y value is going to be equal to k minus j XOR b. So if it contains that, I am just going to get the frequency of that. So map.get xor.j.get k minus j XOR b, right? And I'm going to add it into my answer, right? So let me just declare an answer variable here. So this I'm going to do for all possible values of j from j is equal to 0 to j is till k, right? And once that is done, what I'll do is I will also update the frequency of my current xy into this map, right? So first what I'm going to do is, I'm going to check if this particular x already existed in my hash map. If not, then I'm going to put x and a new hash map. So basically here, I'm creating a new 2D array, right? And then what I'm going to do is get x dot get y. Right. I'm going to update the frequency of y as well. So again, this is get or default y comma 0 plus 1. So what this means is that if for this particular x already an element y existed, then I'm just going to increment the frequency by plus 1. But if this y was not already there, then by default take the frequency as 0 and then increment plus 1. And then at the end what I'm going to do is that I'm going to return my answer. So let's run this code. Okay, so just confusing here with b, we had actually y here. Okay, awesome. Let's run it now. Okay, integer cannot, okay, which is contains key. Okay, awesome. So this particular solution works. Let's just go ahead and submit it. So what we can see here is that the thing that we had to notice here was that k is still 100, right? So maybe we can manipulate this somehow. So this is why the constraints in any particular question are so important. So finally, let's move on to the last problem, the hard problem. So what is given is that we are given a simple directed graph with n nodes, labeled from 0 to n minus 1, and the graph would form a tree if its edges were bidirectional. It's not bidirectional, but if the edges were bidirectional, then it would form a tree. And we are given edges ui vi, and what we have to do is that an edge reversal changes the direction of an edge, right? So if it was pointing from u to v, then it will point from v to u. So let's just take this example. We have 2 which points to 1, and then we have 1 which points to 3, and we have 2 which points to 0, right? This is the original graph that is given to us. And now if I try to reverse the edges of this particular graph, what will happen is something like this. 1 also points to 2, and 3 will now point to 1, and 0 will also point to 2. Now what will happen is that your task is to independently calculate the minimum number of edge reversals, right? We have to, like, let's suppose all of these red edges, they will cost us 1 coin. Let's just say it will cost us 1 coin. And what we have to do is we have to, like, return an integer array answer where answer of I is the minimum number of edge reversals required, so that it is possible to reach any other node starting from node I through a sequence of directed edges, right? We know for a fact, like, let's suppose what if this particular problem, right? Let's suppose what if it was already a tree, right? So if I have something like this, 2 0 1 and 3, then we know that for a tree we can reach any node starting from any node, right? But here the problem is that this is a directed graph, right? And now what you have to do is, for every particular node, you have to calculate the minimum number of edges required, so that if I start at this particular node, right, I can reach every other node, right? So what you'll do is, basically you will not do anything. You will just do a simple DFS starting from every node, right? And one thing that we know is, like, let's suppose I want to calculate the answer for 0, right? Like for this particular node 0, I want to calculate what is the minimum number of edges reversals that I require. Then what I'll do is I'll just start a DFS from the 0th node, and I will traverse all the edges. And what I'll do is I'll do this for every node. Now if I do this for every node, the complexity would be O of n square, right? And then again, let's have a look at the constraints. So the constraints say that n is still 10 to the power 5. Then again, that will not work. Now what I have to do is I have to optimize. So when I start doing a traversal, right, from every node to every other node, what will happen is that there might be some overlapping subproblems. Like let's suppose from 0, I'm going to 1, 0, I'm going to 2, and then from 0, I'm also going to 1, right? Then let's suppose when I'm doing a traversal for 1, right, there comes a case when I'm again going from 0 to 1. So this is being seen again. Now, whenever we have overlapping subproblems, what do we first think of? We think of DP. That means what if we store it, right? So the first thing that you have to do for this particular problem is that you have to create a graph, right? So what I'll do is I will just go ahead and create a list of integer. What I'm doing is I'm creating a graph. So one will be the original graph that I have, and one will be the reverse graph that I have, right? So I'm just gonna go ahead and insert the edges here. So first I need to add a new array list for every, let's say, node, right? And then after that, what I'll do is I will go over these edges, edges to edges. Let's say u is equal to edge of 0 and v is equal to edge of 1. Now, if I have to create this graph, right, I know that in this particular problem, there is an edge from 0, u to v, right? And if I need an edge from v to u, then this will cost me 1 point, okay? So what I'll do is for the graph, I will directly add graph.add u, graph.get u dot add v, right? But for the other one, for the reverse one, what I'll do is I'll get v and I'll add u, right? Now what I have to do is I have to return an answer array, right? So let's initialize that first. And what I'll do is I will just go ahead and do a DFS over every node, right? And I will say that my result of I is just going to be equal to DFS of I minus 1. Now, whenever we are doing traversal over any particular graph, right, what we have is that it's also a tree. And in any tree, every node will have one unique parent, right? That is the property of any particular tree. Like if I have a tree, it won't be like it has, if I start from any particular node, right, and I do a traversal, then any node will have only one parent, right? And what is given to us in this question is that it's a simple directed graph, but it would form a tree if its edges were bidirectional. And if you notice here, what we have done is I have created this graph and in a way I have made it bidirectional. So now I know for a fact that I can treat this particular graph as a tree. Now what I'm going to do is I'm going to do a DFS for my current node, and let's say my parent is equal to parent. Now, what I'm going to do is I'm going to calculate the current answer. So first, my priority here is that I have to find the minimum number of edge reversals, right? Now to find the minimum number of edge reversals, what I'll do is I will first traverse over the original graph that is given to me, because the original graph is directed, right? And the edges that are in my original graph, I do not have to edit them in any way, right? So what happens is, let me just go over all of the neighbors. Let's say, or let's call him int x is to graph.get node. First thing I'll check is that if x is equal to the parent, then continue, right? Because I do not want to be stuck in a cycle. Because let's suppose I have something like this 0, 1, 2. Now if I'm at 2 and I go ahead and check that 1 is like the particular neighbor, and if I go into this one, then I'll be stuck in a loop. I'll be going over 1, then 2, 1 and 2. So that is why I just check if it's a parent. So if I've come at 2, I have come from 1, right? I'm not going to go back to 1 again, right? So that is what I'm going to check here. So if x is equal to parent, then I'm going to continue. Otherwise, what I'm going to do is I'm just going to go ahead and traverse over the parent x now, right? And I will update the parent because the parent will become the current node. Similarly, what I'll do is once I have given priority to my original graph, now I will go ahead and traverse over the reverse graph. And similarly, here also I'll do the same thing, that if x is equal to parent, then I can continue. Otherwise, what I'll do is I will add it into the answer. X comma node. And now here what's happening is I'm traversing over the reverse graph, right? And for every reverse graph, I know that if I include this particular edge, it will cost me 1 point, right? So I'm going to add a +1 here, because what it means is that I'm traversing over an edge which was not given to me earlier. So this is a reversed edge, and I'm going to add +1 to it, right? And once that is done, what I'm going to do is I'm going to return my answer. Now, what's the problem in this particular problem is that this is an n square problem, right? And like I said, there's going to be overlapping subproblem. What I know is that this x and node, this particular node and parent, I can store this so that if I am traversing this particular value again, right? What I can do is I can just get it from my DP array. So what I'll do is I'll just create a DP array here. Again, this is going to be a 2D DP array because basically I'm storing a pair, right? So in Java, this is how I'm implementing. You can also implement the pair class that comes in Java. And now first thing first, what I'm going to check is that have I traversed this particular node and parent combination before? So basically, have I traversed this node and parent before? So if dp.contains node and then dp.getNode.contains key parent. Basically, if this particular is already existing, then what I can do is I can directly return this value, right? Because why do I calculate it again? But if I haven't, then I'm going to calculate this particular answer, And once it is calculated, then what I'm going to do is I'm going to put it in my current DP array. So if not dp dot contains key x, then first add a new hash map, and this is equal to node, right? And what I'm going to do is dp dot get node dot put parent comma answer. So now I know for a fact that if I ever traverse this particular node and parent combination again, then I will have it stored in my DP array. And then what I can do is I can return this result. So as you saw, this was a problem of simple DFS only, because what you had to do was you just had to store the things that were being that were being calculated repeatedly. So as we can see here, that the graph would have been a tree. So that is your cue that maybe you can just treat this particular graph not as a directed graph but instead as a tree. And then one property of tree that you had to use was that every node will have only one parent. So what I know is for any particular node, I know this node and parent combination will remain same, right? No matter what node I start traversing on, right? So even if I'm going over each and every node, this node and parent combination will not change. And that is how I can use it to solve my particular problem. And then I can just return it. So this, as you can see that for the original graph, we do not count any point. But if we are going over the reversed graph, then we are going to include +1. And if this node and parent was already stored, then we will return it from our DP array. Otherwise, what we can do is we can add it into our DP array. And this was the solution for this particular problem. And yeah, so, guys, that was the complete detailed discussion of the LeetCode Biweekly Contest. Let me know in the comments if this was helpful, and if you have any doubts, write that in the comments too. I will make sure that I reply to each and every doubt. And apart from that, do like, share, and subscribe to my channel as well. And do share the channel with your friends if you found it helpful. That will really motivate me to keep creating more content for you guys. And that being said, keep learning and keep growing. See you next time.